Hello everyone. In this video, I will present a paper named Cloud-based Smart Parking System that is used Internet of Things IoT technology to help improve parking space management in urban area. This paper was written by DJ Dan. In 2015, it was published. It's a kind of original contribution paper. This presentation, I will cover system design, components architecture, evaluation method. This presentation, I will cover system design, components architecture, evaluation method, and the key result. After that, I made the conclusions. So, for this original contribution, where is the problem statement and motivations? The problem is finding parking in urban environments has always been a challenge during this day. Drivers waste of time looking for a available parking spot, which is a deal and lead to increased traffic and air pollution because of higher fuel consumption. For that, there is a motivation for this system. With the urbanization on the rise, parking issues are not only going to get worse. Traditional systems are inefficient and do not take advantages of a new technology like IoT and AI, something like that. So this paper proposed a cloud-based solution that connects parking facility vehicle to a centralized system for a real-time parking space management. So you can see overall system architecture. There's a 3 units that work correctly. First is the parking units, and second is a cloud-based server, and then the mobile app that looking find the space which available or not. So local unit at each car park include the electrical component, RFID touch, a control unit, Arduino Nano or Arduino Uno, something like that, and the display that show the current parking status. Cloud-based server is a kind of receiving real-time parking data from the local units and make this data available to the mobile application. So mobile application allow the driver to view available parking space and reserve a spot in advance. You can see here's 2 pictures. The one is a simple system architecture. The one is how a single car parking unit work. So the cloud server also process data from the different parking facility and automate the space allocation based on the federal distance and occupancy. It collects the data get from all parking area in the specific locations. Here's the key components of the system. Local unit as a kind of a small parking space at each car park, contain beacons for detecting vehicle and tracking the available space. RFID tags are used for authentication, allowing the system to identify, resign, and restore the vehicle. These control units communicate with the cloud server, reporting the space availability to the cloud database. So cloud database manages the parking availability data from all connected car parks. It's use algorithm to process data, determine available state, and relay the information on the mobile application. So mobile application allow the user to see where it's a free space, what is the distance to go that kinds of space based on the proximity and availability. So user can do reserve spot, view direction, and get real-time update. Here is a way structure algorithm flowcharts for the system operation and car parking, each car parking units. There's a well integrated and designed algorithm structure. So for the algorithm parking decision, what kinds of formula or mathematical calculation or consideration is used? The system uses an algorithm to help design the best parking space for the user. The algorithm minimizes total cost, which indicate both distance to parking space and the number of occupying spots in a given factory. The formula is U as we see, where in this formula, dij distance from the user parking space, T represents number of occupying space in a facility, and FR and beta. What are they? They are like weight factor that control how much distance and occupancy affect the decision. So how about stimulation and testing? The system performance will evaluate through stimulation, where FR and beta will vary to assess the impact of the system efficiently and waiting time. The system shows significant improvement in efficiency when the distance and availability were weighted approximately in the algorithm. Simulation results also highlight how the system performs change based on the number of available beacons and car parks in this network. So, result and key findings kinds of standpoint. Yes, the system will test a set of performance metrics and user certification survey. User certification include the system receive high certification rating for its ease of use and accuracy in providing real-time updates. System efficiency is measured with the algorithm was successfully done in optimizing the parking allocation and reducing the waiting time for the user. On the other hand, we can consider about the technical performance. No significant issues were found, but there are challenges with the cost and beacon installation. That's kind of weak point. So here also limitation and challenge to elaborate and develop this. Installation will be expensive and require permission from the building owner. Scalability is a concern for the large park network due to the high development costs. In this feed, they don't mention about the realistic testing or result for the big compound or big area. The system was tested only in limited environment. That's the main point. Long-term user study are need to understand the systems, which is the real-world performance or not. My conclusion: this cloud-based smart parking system provides to be an effective solution for parking space management. It offers a user-friendly experiment for drivers while helping parking managers optimize their space utilization. But on the other hand, there's a few future points to be improved. Thank you for watching to the end.